Hey everyone, it's Joe again. I'm just going to go over parallel and series using addition and reciprocals only. So basically what a reciprocal is your multiplicative inverse. So what that means is if you have a number, for example, like 3, the reciprocal of 3 is 1/3. Or if you have a number like 2, the reciprocal of 2 is 1/2. Or if you have a number of 1, the reciprocal of 1 is just 1. Basically what it means is what number do you have to multiply it by in order to get an answer of 1, or what number do you have to divide it by. So for example, 3 times 1/3 is equal to 1, or 2 times 1/2 is equal to 1, or 1 times 1 is equal to 1. So that being said, let me go ahead and show you guys a little bit about parallel. I showed you how to multiply and to get the equivalency of a parallel resistor. However, there is a way to do it with addition only, and I will show you how to do it with addition only instead of using the equation that I showed you guys. So in here, this is the same circuit we had, 7, 6, 5, 4, 3, 2, 1. Basically, we know we need to reduce this in series, so we know 2 and 1 in series is 3. So the answer here is 3. So now we know that 3 and 3 is actually in parallel, so we got 3 in parallel 3. Well, instead of doing R2 times R1 over R1 plus R2, this equation, what we can do instead is take the reciprocal of both numbers, so the reciprocal of 3 and the reciprocal of 3, and add them together. So we got 1/3 plus 1/3, which is actually equal to 2/3. So basically this is the reciprocal number. So this would be 2/3, but that would be inversed here. So the actual value here is 3/2, because the inverse of 2/3 is 3/2. Okay, so now we know that we have 3/2 here, and we know that 3/2 is in series with 4, which is just the same as saying 8/2 plus 3/2, which is 11/2. So the number we get here is 11/2. Alright, so basically we know 11/2 is in parallel with 5. So we got a reciprocal of 11/2 is 2/11 plus 1/5. So we got 11 times 1 is 11, 5 times 20. So basically we get a number like something like over 55, and then we got 11 plus 10, so 21 over 55. And again, that's the reciprocal number, so the actual value here is 55 over 21. So the next one is 55 over 21 is in parallel with 6, so you do 21 over 55 plus 1/6, and you'll get something like, let's see here, 50 times 6 is 300, so we got 330 on the bottom, and then we got 55 plus 6 times 21, so 126 plus 55, so basically 126 plus 55, you get 181, that's what I thought. So now you have 181 over 330, so basically this is technically 330 over 181, and basically these are now in series, so you got 7 plus 330 over 181, which is equal to the same number that we got before, which was 7 plus 330 divided by 181, which is 1.823. Plus 7, which is 8.823. So if we go back to our answer that we got prior to this, we did get 8.823. So as you can see, it's the same exact thing. They're just done differently. In fact, that's how that formula is derived through, well, you can derive it through nodal analysis, but you can also derive it and then split it off and see that basically, let's say you had 5 was in parallel with 5. That means it's 5 times 5 is equal to 5 plus 5. So in reality, this should equal 1/5 plus 1/5, which is 2/5. Does it equal that? Well, we got 25. And then, and then you have to reciprocate it, so you got 5 halves. So then you got 25 over 10, which is 5 halves is 2.5. So basically 25 divided by 10 is 2.5, which is 5 halves. So it's exactly the same thing. Alright guys, that's all I really wanted to show you on this video. It's just something really neat. It comes in really handy later on, especially when you're working with a lot easier numbers than what we're dealing with here. But when you have a calculator, it's a lot easier to say 1/3 plus 1/3 than it is to say 3 times 3 divided by 3 plus 3, and then keep adding it in that way. I mean, I guess it's not too bad if you can define it as an answer and then just keep using the answer as the next parallel or the next series. But that being said, I do want you guys to leave comments, so please leave any comments or any questions below. And again, if you guys are collaborating, you will learn more, so please do so. Thanks again, and I'll talk to you later.